Good morning, Gary from G&H Honey Bees. I've had a couple of subscribers ask me about my sugar water feeders that I use in my inner covers to feed the bees, either sugar water or dry sugar. And one of the questions was, does my sugar water, the feeders that I have now, will they fit in my nukes? And the answer to that is no, they don't fit in the nukes. They're too wide. They're too big around. So I thought I'd sit down and show you how I make my 3D stuff, draw up my 3D stuff for my beekeeping, and what I'm going to do up as a design for a sugar water feeder that will fit into my nuke box feeder boxes. So to start with, this is a program called FreeCAD. Excuse me, and it's freely available for Windows, Linux, and Mac. It can be quite daunting to start with if you've never done 3D design before, but there are a ton of tutorials online about how to make this program work. And I just learned how to use the software by watching tutorials. So to begin with, the program has to be set to this option here, part design. And now I want to click on this, create a new document. And then I want to create a new body. And I want to create a new sketch. And I want to set the base plane to the XY base plane. And click OK. So now I've got a new empty drawing document. And the sugar water feeder is basically going to consist of 4 circles manipulated in different manners. And I'm just going to show you how quick and easy it is to do this. So you click the circle drawing tool. Draw a circle somewhere near the middle of the XY base plane, and then you click on the center of the circle, and you click on the center of the XY plane, and you click this button here which centers them or aligns them. And if I do that same alignment on all the circles I'm going to use, everything's going to be concentric. It's going to be even to each other. So now I have this circle on the screen here. I want to enlarge the circle to the outside dimensions of the dish. And I've already figured that all out, and I want the dish to be at least 5 inches across, and that sort of equates to 128 millimeters. Now this program measures the circle from the center to one side. So 128 millimeters, I want to make this circle setting here 64 millimeters. So I click on the arc function up here on the top. You just click that, and then this dialog pops up and I can enter 64. And you see that immediately enlarges the circle. I'll just zoom that in a bit there. And then now you see here on the top left it says fully constrained sketch. That means that that's a closed sketch. That means that you can do another operation on it now. So click close. Now I want to pad that circle. So I click the pad function, and it's gotten big again. Move it back to the center. And I sort of tilt it a little bit. Now you can see that that circle is turned into a disc. Now the default dimension for a pad function is 10 millimeters. But I want the dish to be 64 millimeters deep, so I just enter 64. And that stretches that circle out into a cylinder that's 64 millimeters from one top edge to the bottom edge. And I click OK. Now I want to make the inside of the dish. So I click on the top of the cylinder, I go up here on the left, create a new sketch. Want to grab the circle. Want to draw another circle. Want to center that circle. And then I want to set this circle to 63 millimeters. Now you can see that that circle is just shy of the outside diameter, which is going to give me like a 1 millimeter thick wall on the outside of my dish. So now you can see that's fully constrained over here on the left. So I close that, and now I want to do what's called a pocket function, which is basically going to make a hole. Now I want this the bottom of this dish to be 1 millimeter thick. Now, seeing the outside dimensions from there to there, 64, I want to make this pocket 63 millimeters deep. And there we have the outside of the dish with the bottom. Now, to make the center part, you click on the bottom of the dish, create a new sketch. Want to put another circle in the middle here. Want to center that circle. And then I want to set the dimension of this circle to roughly 2 inches or 50 millimeters. So I click the circle function, and I want to change that to 25, and that will give me a 50 millimeter wide circle. Now that's fully constrained up here again, so I can do another operation on that. And I want to pad that. Tilt this over a bit. Now you can see that that center has been padded up 10 millimeters because of the default 10 millimeters that the pad function does. Now I want this center post to be 50 millimeters high. Now seeing that the bottom of the dish is 1 millimeter thick, I want to make this post 49 millimeters. Click OK, and there we have the center post. And to make the hole in that, I click the top of that post and go back up here to the left, create a new sketch. I want to grab another circle function, draw another circle, center that circle, and then I want to make that circle 23 millimeters. And again, it's fully constrained, so I'm going to close that, and now I'm going to pocket that circle, and I want to make that 50 millimeters so that it will stretch all the way through the entire body. And I click OK. So now that you can see, I have the basic feeder dish. And the only other thing I want to do is these bottom corners where the walls meet the bottom, that's a 90-degree angle, but I want those rounded. And the same where the center post meets the bottom of the dish, I want that rounded. So I want to click right on that line between the bottom and the side. You can see, I don't know if you can see that, but it turns green. And then I want to do, up here on the left, I want to do the fillet function. And I want to make that fillet 5 millimeters. And you can see that's made a round section here. So the bottom, so the side goes down and then it's sort of rounded out and then it meets the bottom of the dish. Now I want that same effect to be on the center post here. So I'm gonna, while I have this menu open on the left here, I'm gonna click Add Reference, and I want to get on that line for the post where the bottom, where the post meets the bottom, and so I put a round corner on that as well. So that's it. That's the sugar feeder. Very simple, very easy to draw out. And when it's all printed out, it'll be very functional. So what I have to do to this now, because this is basically a solid 3D image or an object, I have to turn it into a form of how do you say that? I have to turn it into a form that can be further processed into a code that the 3D printer will understand. So I have to go up here to this, close that window there, go to part design, and I want to click on mesh design. And what I'm basically going to do is turn this into like a 3D mesh or netting of this whole dish. So I go up to meshes, create mesh from shape, I grab all of that, click standard, and I click OK, and now I have complete 3D mesh. Now you can see in this menu here under the model, you can see all the different parts. That pad is the original outside of the dish, the pocket is the inside of the dish, that pad is the center post, and that pocket is the hole through the center post, and of course the fillet is the round corners. And so the meshing has done, has meshed each piece of that, and the bottom one will be the complete piece. So I want to right click on that, and I want to export that mesh, and let's go nuke feeder. As you can see, I've already done this, but I'm just going to redo it again. And that's it. That's it for this program. So now I'm going to open another program that will further process this model into something that the 3D printer will understand. So I'll be back in a moment. Alright, so I'm back. Now I've opened up this program here. It's called Kira, and it's called a slicing program. And what it does is it'll take that solid 3D model and it'll slice it into layers that the 3D printer will understand, and then produce a code that is basically a list of XY coordinates that the printer that tells where the print head is supposed to be at any certain given time. So let's go File, let's open that feeder. Oh, I got the set on the wrong view. So there's the solid view. There's our feeder. And this program's already done what it's supposed to do just by loading that in there. It automatically takes that object and it slices it into layers. And if we go on layer view here, I don't know if we can zoom in on that a little bit. You can see layer by layer if I pull that down. So the printer is going to start at layer 1 here, and it will build this object from the bottom to the top. And that's basically all this program does. Now it all depends on all your settings here, which I've had to tweak quite a bit to make it work. And down here in the bottom right, you'll see that it's going to take 10 hours 59 minutes to print this dish. So this is one of those sort of things you start at first thing in the morning and you go off and go about your business for the day and come back, it might be done. Now you can either save it to a file or you can save it onto an SD card. Now I usually save it onto a mini SD card, and I take that mini SD card and I install it into the printer, and when I turn the printer on, I'm able to read that file directly off the SD card, and the printer will then start working on printing out the object that you've designed. And in this case it would be the dish. So I'm going to stop this here for now, and then I'll move on to the printer and some other things. Alright, so I'll be back shortly. So the SD card, my finger out of the way, goes into that little spot down there. Point to it right there. You just plug that in, turn the machine on, and you can read that file off of there. The printer can read that file off of that SD card and print it out. Right now I've got the caps printing out, and you can see the print head is just going back and forth, laying down one little ribbon of plastic at a time as it moves across. And that's why 3D printing takes such a long time. So this 3D printer that I have is just a cheap $200 Amazon special. It's a what they call an ANET A8 replica, and I made modifications to it. You see the yellow pieces are stabilizers that I printed out. I had to print new footings for the vertical axis motors. There's one on each side, one over there. And of course I printed out this wire chain. Without the wire chain, the wires on the top of the print head were moving back and forth because of the way the print head moves, and they were actually snapping off and causing issues. Now it seems to be much more stable. You can see other red parts in there, like the fan shroud on the front of the print head. And there's a plate in the back of the fan there, that red plate. That holds the sensor for the height adjustment. And on the back here, I've modified the power input with this electronic module here. I can't remember exactly what it's called, but what it does is it adjusts the power feed to the print bed so that it doesn't overheat the print bed and cause a fire. Anyway, so that's the printer setup, and because this is only one color, right now I've got a spool of clear in the spool holder that I printed out. And I'm printing out the caps right at the moment. And when the caps are finished, I'll change that clear spool for a spool of white PLA plastic, and then I'll print the dishes out. And then once I get everything printed out, it'll take some time, of course, I will add it to this video, and so you can see what it actually looks like when it's all done. Alright, so I'll be back in a bit after everything's printed. So here's just a quick shot of the printer working on the bowl that I did up in my 3D design. It's at about 19% done. It's going to take the rest of the day to finish this. So here I'm back. It's been a full day since I started printing that mini dish. So what is sitting here in front of you right now is the full-size dish that I print out for the the 10-frame hives. There's the center for feeding sugar water, and of course the cap to keep the bees in. So now here's the mini dish. So you can see quite a bit of size difference in those. The lighting's not very good in here, but there you have it. Bees just come up through that center hole, feed on either sugar or sugar water, depending on what season it is. And of course that goes in the center to put sugar water in there, and then the bees can just feed on the sugar water in the center and then go back in. And of course then you have the cap to keep them in. And this cap, I'm going to redo these caps. I don't know if you can see it too well on there. You can sort of see through them caps but I made them a little too thick, so I've reduced the thickness on this part here in my design, and I'll print them again and see how clear they are. And that's the nice thing about rapid prototyping on a 3D printer. If you don't like the first go around, you can always change it a bit and then try it again. So there you have it. That's my indoor project, because it's been pouring rain for the last 4 or 5 days straight, and you can't really get into the beehives to do much of anything. So that's it for the sugar feeders for my nuke boxes. And the nice thing is about this sort of deal is I built my feeder boxes, or kind of a custom build for my nukes, so I wouldn't be able to find anything like this on any commercial market. And so it's nice to be able to sit down and just design your own and make your own in this fashion. So anyway, I think that's all that I have for now on this building the nuke sugar feeders. And I want to thank you for watching, and please keep on watching. I'm going to do more. Bye for now.